right. Which main contract do we start from? Do we go to the pool again?
Let's go to the collateral tracker. Let's see. Token ID risk parameters. Let me see the imports first. I like to see them. Just oh,
What, what
it
go?
okay. It imports a pool. Okay. I think I got the picture.
What? I mean, I wanna know what you thought right now. My thoughts are if it imports a pool and the currency, collateral tracker should track the collateral in the pool.
Mm-hmm. Yeah.
I mean, did you thought the same or
Yeah, I mean something like that. I'm not sure. Let's just see the code.
yes, 20 minimal? What you call
So this is a clone. This
this?
is not a
This
standard clone.
ERC 20 minimal. Are you familiar with it?
Let's take a look at these imports. Just open them. Is this in scope or where is this from? Where can you see the repo? Who made this?
Clone panoptic.
Huh.
It's a library,
That's fine. So immutable arc. Okay. Read immutable arguments from call data.
but this is not in scope.
Yeah, it's
I'm
fine. I
sure it's.
just wanted to know how it works. Yeah, I think I've seen, but it's not in scope. But it's probably not important. Let's just see what functions it has more. Can you just go down just to see? So this is just to get immutable. This is just to get arguments. This is probably like a way for clones to set immutable values. Because it's a clone. It's a proxy. It's a kind of proxy. So you can't use the constructor. So they use this as a workaround. Some kind of trickery.
Yep.
So
Okay.
let's go back to the collateral tracker. Well, and then this ERC20 minimal, what is it? It's just basic functions. Proof.
Transfer approve. Transfer from.
It's
Yep. Just the basic ones.
regular stuff. Okay, cool. And the multi-call should be the same we saw. Yeah, it's fine.
Yep.
Okay.
So constants.
Panoptic.
Okay. So they named their precision unit decimals.
Yeah, it's a basis point. Normal.
Yeah. Yep.
What? Mask 0,
2018.
the value between bits. How are we going to know how many? Like, is this mask really is this really bits 112 and 150? How are we going to know? So we need to count the number of Fs.
Or just ask LLM.
But does it? I don't know how accurate it is for this. I don't know if I trust it. because it's easy to get
Okay,
like just
do we
copy it.
count it?
No, I mean you can use some character count tool or something. Oh, you know, it says VS Code tells you, look, it's 28 selected on the bottom right. 28 selected, right? This is
Oh,
actually just, yeah.
yes.
Try to select just one just to see if it works correctly. Like select just one or two. What happens? It works, right?
Once. Yep.
Cool. Cool, cool, cool. So 28 Fs means 28 times 4 bits, right? So 50, 56, 112. So this is 112 1 bits.
Yep.
Exactly. And if we start at bit 0, it means it's from bits 0 to 111. So the bit 112 is 0. Now count the number of zeros. Let's see. 9. No, it's not 9 actually, because C is 10, 11, right? C.
10, 11?
No, wait. I think 10, 10 is A. 10, 11 is B. It's 11, 0, 0, I think. So there are two zeros in C. There are two zeros in C. Plus 9. 9 times 9 times 4, 36. Plus 38 zeros. Bits. And 112 plus 38 is 150. Okay. It takes so long.
Yes.
What the fuck, dude? It's trying to
Yes. Too slow.
hallucinate. I feel it.
What the fuck?
it needs to. It needs to make all this shit. It's just to waste tokens, bro.
Yeah, I'm not wasting anything because
It's
I've
auto.
already hit my limit. So
This thing is optimized to make you waste. Yeah, so there are 9 zeros, right? So it's 36 total bits plus
yep.
2. So 38 bits. So it's bit 112 to bits 150.
Yeah, got it right at the end.
It's not, but 150 is a 1 bit, I think, already. It's like 112 and 149, right? Because 149 minus 112, it's you need to add 1 to the difference to know the number of bits, right? So what I usually do to make this easier to understand, because there are lots of zeros, like you can't really count. It's weird. So if you think about it, I like to think it about this way. Okay, if it was between bits 112 and 113, right? We would have two zeros, two zero bits, right? Two zero bits. But the difference between 113 and 112 is just 1, right? Which
Yep.
means to get the number of zeros, you subtract, so 150 minus 112, which is 38, and then you
38,
add
yes.
1, so 39 zeros. But we only have 38 zeros, right? So it means this is actually between bits 112 and 149, I believe, which is not a maybe it's not an issue, but just it's a bit confusing, the comment, right?
Yeah, it depends if the next
Like, ask the LLM just to confirm. Let's see what it says. Like, ask it like what bits are set to 0. It's probably 112, 149, but just to make sure. So it's 38. 38 bits. Okay, let's continue. Not deposit. I like how they use flags for false and true. Nice. Is not deposit flag. Very pretty.
listed assets by AMM. Do they mean Uniswap, or it could be
Probably, yeah. I would.
any MMM?
I don't know. Could be any. I don't know. So they have some credited shares. Okay. Let's keep going. Go down. So now tell me, what? Don't go look. What state variables do they have? You need to tell me. No, really, this is something I
Deposited assets.
yeah, exactly.
Um, and I forgot the other two. I remember
I do
there are
this
two
like
more,
I
but
do
I
this
forgot.
internally. Every time I memorize the state variables. It's very important. You can do it later. Let's continue.
Okay.
Motherfucker, like this LLM is slower. Look at this shit. Why is it so slow?
Yeah, I don't have an idea. I don't know. It it's all like now. I I don't know why. What's the reason?
It's stuck.
It's probably thinking, but oops.
Okay. So underlying is token 0. What the hell is it? Shift right. Calculate load offset 20. Uh, Oh, but this okay. This is from the immutable args. Yeah, this is how they. This trickery. They explain this. They have look at the comment above. They show how they. No, no, not that one, dude. Like 1150 line. Yeah, that the big shit. Yeah, so it's the pool underlying is token 0, underlying token 0, token 1. Yeah, yeah.
Risk engine.
Yeah, it doesn't match the comment above. Again, look, it's different. Then it's not the same. It's missing two things,
Pool manager is missing in the code.
and risk engine as well.
Yep,
Okay,
risk engine as well.
that's fine. But yeah, so basically that's why they add 20 to this offset. Because the underlying token is from bit 20 onwards. You know, the first 160. So do you know why there is a 20 there? Now that you know a bit about bits.
Here,
Yeah, why is it 20? Do you know? It's 20 bytes, So 160 bits. Yeah. So they load and then they shift right by So you got this why they load this offset with 20, right? This call data load. Do you understand this shit?
Wait, so this 20,
Yeah.
these are the bytes.
Yeah, it's the bytes. It's how they store the immutable args trickery. They want to get the underlying token, so they get the call data from 20, from byte 20 to, you know. So call data load reads the full word, so it reads 32 bytes, right?
Yep.
But
Okay.
32 bytes, if you read it, you will get the underlying token. You'll get the underlying token is zero flag, and the underlying token address, because it's 32 bits, 32 bytes. So it will go from byte 20 to 52, and we only want the byte underlying token. So we just want to read one byte, right? So we need to remove all the shit to the right to
Wait, where are we starting from?
from zero. Zero
Left
is
to right
panoptic pool.
or right to left?
It's left to right, yeah, left to right.
Because in the types, they've started from right to left. That's why I got confused.
Okay, okay. I mean, you need to check if it's consistent, right? But I mean, let's say it's for now it's consistent. Let's just say. But I see what you mean. Like, yeah, I mean, because it's the other way around. So yes, I
Yeah.
understand. Exactly. But it doesn't matter. Like, as long as it makes sense, we need to see how they. So if they store it as they say in line 149, you know, with the
Yep.
ABI encode. But if they store it like this, it's it should be correct. But it's actually easy to test this, so it's not a problem. So let's say this is correct. So they get the byte 20, and then they shift right by f8. Now, how much is f8? Them, my hexadecimal is rusty.
Yeah.
There
I
is a
mean,
trick to calculate how much this is, but
how do we
honestly, I
know
don't
this?
remember.
Yep. Should we know this like right like remember them or
I mean,
because
like the thing is, I haven't thought about it for long, so I forgot. But like, if you understand it once, you'll probably remember for some time, and the next time you forget, and you learn it again, it's much faster. It's
yeah.
instead of learning, you're just remembering, which is easier. But yeah, so can you show can you open like just how much, just ask in the somewhere in the browser or something, how much is 0xf8? I think the browser can tell you. Like, it's faster than this LLM. It's taking a lot of time. Just write 0xf8 to decimal. Okay. Yeah, 248. So yeah, they shift right this number of bits because they just want the upper byte. They just want the underlying is token 0 byte. So they have to remove 248 bits from the 256 bits word. you know
So they have these 8 bits only and they take the underline.
yeah, they just want that part, basically, because they when they do call data load, it loads the underlying token flag, the underlying token address, and a part of token 0, because it's all continuous. So yeah, let's keep going. You can go through this afterwards. So yeah. So they have this helper. It's so what this helper does for. Can you open the helper just to see? We were at it. It's the get arg address internal function. Yeah. So it loads an address from the offset because it shifts right.
That's right.
60. How much is 60? Can you do the same for 60? Got them. Yeah. Okay. To decimal.
96.
Yeah, so they remove 96 bits. Okay.
D shift right 96 bits.
Yes. Now can you go back? Okay. Yeah, exactly. Because so they get byte 21. Now if you go to the comment above, go take a look at the bytes comment. Yeah.
21.
So byte 21 is the token, the underlying token, exactly. And they only want 20 bytes, so they remove 12 bytes, which is 96.
So byte 21 to 41 is the underlying token.
Exactly. Yes. So they shift right because when they do call data load, it brings 32 bytes, so they need to remove the extra 12 bytes that would be a part of token 0, when they need to chop it off. No, to the right. Yeah, it's when you load 32 bytes from an offset, is like from 21 to the right. Yeah, 41 and then plus 12. So it would go until byte 53, basically. So they need to remove those bytes. Yeah, okay,
Okay.
let's. But you should test this just or see if they have a test. If they have a test, it's fine. So
Okay.
token 0, same logic. Can you go see what is token 0 now? It's token 0, token 1.
Token,
Yeah. Token 0, token. Yeah, it's correct.
token 1. Yep. Risk engine 81. Bull manager 181. Okay.
Pull fee.
Bull fee.
Yeah, pull fee they need to do manually because they don't have a helper for that. But it's the same. So 0xe8 should be 256 minus. How many bytes is this pull fee? It's 24 bytes, right? No, it's 24
Yep.
bits. So
24 bits.
it's 256 minus 24. So it's 230
32.
32, yeah. So you need to see if 0xe8 is 232. Yeah, okay.
Yep.
Yeah, looks good. See, bits are easy, man. Right?
Yeah, I guess.
Like it's just some math operation or something. Like,
It interested. Do you read these comments at first sight?
I mean, I think you have to in this case because they tell you how they store. This is basically they are doing the same thing. Like they store the information in an optimized way, right? In a single word. So, but actually, you don't need to read this actually. If you open the market state type, you will go through the market state type, and you will know what market state, how if it works, their storage. Once you know that, it becomes much easier because you just use the market state struct, which you know is correct, right? Because this is a struct or not, like this market state. No, it's not a struct. It's a word, and then they have getters, right?
Yes, 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 yes.
They have getters,
It's
isn't
a
it,
word.
right? They fetch. They call these functions to get, yeah, to get the. Dude, this is so much more complicated
Here
than
it is.
having
Yep.
a struct. Really, like why? This is just so annoying, bro. Okay, let's go back. Yeah,
Interested.
I hate this. I honestly hate this. Like it's so much harder to audit.
Yep.
Because if you have a struct, it's so much easier to remember all the state variables and stuff. Like you don't have a struct here. I think maybe you need. Can you open the market state type again just to see something? Can you go up? Do they have a comment with all the storage?
Yep. Here it is.
But it's so much harder to remember. Like you have to remember like it's the unrealized interest rate at target market epoch borrow index.
Yep.
Okay. Okay. Cool. Let's just go back to the function. This commission fee must be immutable, right? Because it's in the constructor. Yep.
Immutable. Yep.
Okay. They have initialize. So they virtual shares.
Yep.
Cool.
Storage book. Uh,
So they set total additions. 1 divided by virtual shares. Okay. Wait, why are they shifting block timestamp right? What is this operation? Isn't this a shift right?
yep.
So the epoch.
Looks like an epoch. Yeah. You want 32.
So they shift right. Shifting right twice is like dividing by 4, I think. So the epochs
Why are they shifting twice?
it's how they
Was that?
track epochs. They divide by.
They just divide by two times.
Yeah, they divide by 4 basically.
Yep. Okay, just they're storing it right
Okay,
in
so
the wall.
you know what? Like this is actually, I think this is easier to understand with bits. So for the so they shift right 2 times, right? So
Yep.
the epoch is like the upper 20, the 30 bits, right? Because this is 32 bits. So for the epoch to go up, it means the the least significant 4 bits need to increase, right? And for need to be set to 1, so it then increments the 30 bits in the left. Not it's not 30, it's 28 bits, because dividing by shifting right twice. No, sorry, it removes 2 bits, it's just 2 bits. So the epoch changes every 4 seconds. Can you ask the LLM this just to verify? I think it's easier just to see, like.
Yeah, we still haven't got an answer on our previous.
Yeah, I think you're being rate limited or something, bro.
uh, I don't know.
What the hell?
Okay, I think it was written somewhere that an epoch will be 64 seconds. Not sure.
But 64 seconds is not shifting. The thing is that is not shifting too. Like it should
Okay,
shift.
what do I ask it? How do I structure my question?
Just ask it what is. Just ask it what is the epoch duration. It should be. This doesn't look right. I think. I mean, if they want 64, they should shift. Um, I don't know, 6 times.
That
I think it's six. Yeah, 6 times.
4 seconds.
Yeah, exactly. You see what I mean? Like it's 4 seconds. Why? Interesting.
One epoch is booked half set times time divided by 4.
Yeah, it's supposed to be 4 seconds. Do you know how why it is 4 seconds? So write in the comment box. Write a number which is in binary. Write like 0000. So they shift right uh, 2 bits, right? So it
Okay.
remains, all you get is the left 2 zeros, right? So it becomes 00, right?
Yep.
1 second passes. So now it's 0001, right?
Yep.
No, no, right below it. No,
So
keep that and below. Yeah, now write 0001, right? So, and then shift right to 2 times. So it is still 00. The left the result is 00 of this,
yep.
because you remove 0 and 1.
I removed the one.
And 1 second passes, so another second passes, and now it's 0010, right? Because you add 1. So you shift right and you remove the 10, so it becomes 00, right? And now
Yep.
another second passes, so 0011. You shift right and it's still 00, right? So now four
Yep. It's
second
still
passes,
0.
so it's 0100. So you shift right and now it's epoch 01, you know? That's why it's for That's why it's 4 seconds each epoch.
Eh, Wait, if we shift 0100, it wait, it's like it becomes like that,
Yeah,
right?
exactly. So it's epoch 1, right?
Oh, yep,
Because it we had to add 4 seconds, right?
yep.
So it's how it works basically. That's why in this case it's actually simpler to explain in terms of shift than division, I'd say. If you think about division, you can also think about the rest, because
Okay.
when you divide by 4, the rest is between 0 and 3. So, and the way the rest works is like, if while the timestamp increases by 1 each time, the rest also increases by 1. So if the rest is 0, if it divides by 4, rest is 0, right? And then you add
Yep.
1 to the timestamp, the rest becomes 1, and then becomes 2, then becomes 3, then the epoch increases and the rest goes back to 0, right?
Yep. So
Okay, cool.
yeah, yeah, yes, 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 yes.
Cool. Okay, let's keep going. Oh, we already passed the lesson time.
Did we- Yeah, these bits and shifts and everything taking so much time, bro.
Yeah, but it's just the first time you learn it, because it's
Exactly. Yeah.
not complicated. It's like addition or something. But you don't learn bit addition in elementary school.
Yeah. Yeah.